We know what's the most likely, the other likely possibilities, and the unlikely possibilities. We still don't know what's going to happen. So knowing the probabilities does not eliminate the uncertainty. I work with a professor at Wharton named Chris Getze, and the way he put it to me one time, we live in the sample, not the universe. In other words, the universe statistics, like I just explained for the dice, determine the things that could happen, and maybe they're a possibility. But we live in the sample. We only have one outcome, and therein lies the uncertainty. A great way to think about this is on Super Bowl morning in 2016. They had a former football player on, and he said what I thought was one of the smartest things about probability I had ever heard. This game was Denver versus Carolina, and Carolina was heavily favored, and they asked him who he thought would win. And he said the following: Carolina wins 8 times out of 10. This could be one of the two. Now, this gives you the essence of probability and the essence of risk. Most people, if they hear that something's 80% likely to happen, they say, well, then I guess we know what's going to happen. I guess they might as well not play the game. No, 80% likely means that the other team should win 1 game out of 5. So we have to play the game because we have to figure out which game this will be. And that leads to number 4. I take Dimson's statement that risk means more things can happen than will happen, and I turn it over. Even though many things can happen, only one will. Thus, the expected value, the probability-weighted average of the possible outcomes, which is the basis on which people make many decisions, it can be irrelevant. They take each outcome, they multiply it by the probability, they add them up, and they get the expected outcome. And many people will say, well, we're going to take the course of action that has the highest expected value. But sometimes the expected value isn't even among the possibilities. Now, this sounds highly counterintuitive, but think about this. There's another problem with expected value, because even though course of action A can have a higher expected value than course of action B, course of action A may include some possibilities that you just can't live with. Maybe course of action A includes some remote possibility that you lose all your money. And even though it's highly unlikely, you may say, I just don't want to contemplate that. So you don't take A, you take B instead, which has a slightly lower expected value, but without the risk of ruin.